place that have a high noise level for a long time must hazard to hearing. In this measurement, a Chinese restaurant and a peak dining hour has been chosen to conduct the measurement. The aim of chosen peak hour and Chinese restaurant to conduct the measurement is to investigate the workplace noise level and how high level of noise level or impact to workers who need to exposure in noise for a long time. Generally the noise level will be high in lunch peak dining hour. The data that collect in peak dining time will be representative to noise pollution impact to workers who work in restaurant. In this measurement, parameter LEC, L10 and L90 will be collect and conduct a comparison after measurement. And the noise exposure. On the other hand, possible noise source has been observed due to measurement. In this measurement, precision sound level meter, calibrator and tripod are necessary in measuring procedure. Before measurement, calibration of sound level meter must be conducted to ensure the sensitive of sound level meter, to increase the accuracy of data measured. Parameter LEC, L10, L90 are necessary to measure at two locations inside restaurant to show the different noise level inside a same restaurant. After a measurement at a place, it should repeat the same measure procedure at another position. Then, background noise level are also need to measure. At the end of measurement, a calibration of sound level meter is necessary to conduct once. In the measurement, two locations, 501 and 606 are chosen as the measuring position inside restaurant. The result in LEC, L10 and L90 measured will be shown below. In 606, 30 minutes LEC was 78.3 decibels, and L10 and L90 were 80.9 decibels and 73.6 decibels respectively. To view the trend of noise level change at 606 was ups and downs. Overall, there were 5 downward and 4 upward trend at the measure interval. For the aspect of downward trend had present in minute 0 to 3, 9 to 12, 15 to 18, 21 to 24 and 27 to 30 with noise levels 79.6 decibels to 72.8 decibels, 79.3 decibels to 76.4 decibels, 78.3 decibels, 70.7 decibels, 74.7 decibels to 73.7 decibels and 77.2 decibels to 75.5 decibels respectively. The decrease rate were 1.3% to 10.7%. For the aspect of upward trend was present in minute 3 to 9, 12 to 15, 18 to 21 and 24 to 27 with noise levels 72.8 decibels to 79.3 decibels, 76.4 decibels to 78.3 decibels, 70.7 decibels to 74.7 decibels and 73.7 decibels to 77.2 decibels respectively. The increase rate were 2.5% to 8.9%. Minute 9 to 15 had the highest noise level at whole measure interval. In 501, 30 minutes LEC was 79.5 decibels and L10 and L90 was 101.4 decibels and 76.4 decibels respectively. To view the trend of noise level change at 501 was ups and downs. Overall, there were 4 upward trend and downward trend during the measurement. For the aspect of downward trend was present in minute 0 to 3, 9 to 15, 18 to 21 and 24 to 27 with noise level 81.5 decibels to 76.1 decibels, 77 decibels to 73.6 decibels, 80.5 decibels to 79.5 decibels and 87.6 decibels to 73.2 decibels respectively. The decrease rate was 1.2% to 16.4%. For the aspect of upward trend was present in minute 3 to 9, 15 to 18, 21 to 24 and 27 to 30 with noise level 76.1 decibels to 77 decibels, 73.6 decibels to 80.5 decibels, 79.5 decibels to 87.6 decibels and 73.2 decibels to 75.6 decibels respectively. The increase rate were 1.2% to 10.2%. Minute 24 had the highest noise level at whole measuring interval. For the aspect of possible noise source, the noise source observed can be divided into 8 types. Noise from diners talking, noise from porcelain collision, noise from working of restaurant workers, delivery of foods, noise from television, noise from ventilation system, noise from cooking in the kitchen, noise from cleaning dining tools and noise from working. In a restaurant, the location of seat will be a possible factor that may affect the representativeness of data. If choosing the seat that is far from other diners in the restaurant, the result measured is not representative because the result cannot reflect the real situation of noise level, due to the fact that sound pressure level will be decreased if the sound level meter is far from the sound source. Molecules suspend in air will absorb the energy of sound. Sound will gradually weaken. On the other hand, the time slot of conduct measurement may affect the representativeness of data. It should not measure in latest afternoon base on restaurant, will have a break in the latest afternoon generally. The number of diners are rare at that time. Sound level of sound source are not stronger than at lunchtime or dinner time. Lead the noise level continue low. It is not representative to the noise level in the real situation of a restaurant. The sensitive of sound level meter may be the factor that affect the representativeness of data. The sensitive of sound level meter will affect the accuracy of data measured directly. The data which are not accuracy is not representativeness. So, to ensure the sound level meter is sensitive, calibration should be conducted before measurement and after measurement. To view about the daily personal noise exposure level, according to the noise dose set by the International Organization of ISO, the allowable noise dose set by ISO will be noise level 85 decibels during 8 hours currently. The noise exposure and noise dose that restaurant workers experience daily are calculated below. Daily personal noise exposure level, LEP, D equals 10 log 1/8, 10 to the power of 7.83 x 8, equals 78.3. Noise dose, T1 equals 8 halves carat, 78.3 to 95. T1 equals 8 over 0.197510328. T1 equals 40.50421101. D equals 100x, 8/40.50421101. D equals 19.751038%. Daily noise exposure level, 40.50421101 decibels. Noise dose, 19.751038%. Noise dose, T2 equals 8 halves carat, 79.5 to 95. T2 equals 8 over 0.23325822479. T2 equals 34.2967507988. D equals 100x, 8/34.29675079888. D equals 23.32582479%. Daily noise exposure level, 34.29675079888 decibels. Noise dose, 23.32582479%. To comparing the result with the allowable noise dose set by the International Organization of ISO, the allowable noise dose set by ISO will be noise level 85 decibels during 8 hours currently. At this situation, the noise dose will be 100%. Look back to the result calculated, the noise dose just about 19.8% and 23.3% at 2 measuring position. If an employee is working in the monitoring location for 8 hours, it is much lower than the ISO standard. If the employee work at the workplace with high noise dose for a long time, it is estimated that the hearing of employees will be damaged. So, if the noise dose of workplace exceed ISO standard 100% and noise level 85 decibels during 8 hours, employer should decrease the noise dose exposure time of employees. Make the average level of labor noise exposure on the 8-hour day of work no more than the specified value or equivalent dose value to avoid the hearing damage of employees. For laborers with an average sound pressure level of more than 85 decibels or an exposure dose of more than 50% on an 8-hour day, workers should wear effective earplugs, earmuffs and other soundproofing protective gear.